Hello and welcome. We're going to talk about the rate of change now. The rate of change is something easy to calculate. You just do the difference on the y divided by the difference on the x. Notice here, the difference between these 2 points, that is 4.32, that will be the difference on the y. And we're going to divide that by the difference on the x, that value here. But doing that is quite simple, but what if now I want to calculate the instantaneous rate of change? I mean the rate of change but in one point, let's say in x. So what I have to move should be 0, but if I move 0, I can't calculate the rate of change because I will not have 2 points to do the difference on the y and the difference on the x. So what does a mathematician do to calculate that? He thinks of moving quite nothing. I mean, this is the idea we talked about in class. If I want to calculate the instantaneous rate of change, we think of this little piece that I'm moving being really small. How do we call that in math? Limit of h going to 0. I mean, if h is 0 or almost 0, not 0, but almost 0, the points will be so close that the rate of change I am calculating will be the same as the rate of change, as the limit we calculated in class. Remember that in class we did this limit. We calculate this limit doing f of x plus h minus f of x divided by x minus x plus h. I mean, we did the difference on the y's, f of x plus h minus f of x, divided by the limit, the difference on the x of x plus h minus x. So we did that and we got 2x. But if we want to have this same value here, we must make h really small. Notice, the smaller the h, the closer I am to the value that we found in class. Because, for example, notice that here we are using x as number 3. The closer that h is to 0, the closer that the value that we got as the rate of change is 6. That is 2 times the value of x, which is the value that we got in class for that limit. So notice, I have to make h really small to get close to 6. And here I'm putting h in 0.03, and that is not really small for a mathematician. For a mathematician, that is really huge. I'm talking about the smaller value. So that is the idea here. The limit that we calculate in class is the instantaneous rate of change because we're thinking of moving nothing from the point that we have. So that means that we are calculating the rate of change in an instant, in 1 second, in 1 point, kind of, in 1 point. So that is the idea behind all this. And let me tell you guys that this is the tip of the iceberg for calculus, because then we will talk about something we call the tangent. And imagine the tangent in a graph. Imagine I want to calculate the equation, let's say the slope of this tangent here. This is how a tangent should look like, right? A tangent here on point x should look like this, touching only in point x. But if I want to calculate that, imagine the slope, the gradient of this line, I have to take again 2 points. But if I take 2 points, let's say the same point I'm taking, x and x plus h, and I look at the y's and I look at and I do the gradient of that line, I will have this black line here, which is not exactly the same line I have, the purple one. But if I make h again really small, those lines will look like if they are the same, and they will be kind of the same. In the limit, they will be the same. So the slope I'm calculating, the rate of change I'm calculating, it's also the gradient of the tangent. So look how great. The rate of change, the derivative, as we call it, and f dash, it's also the gradient of the tangent. So look how great. All 4 names for the same thing. The derivative, the rate of change, the gradient of the tangent, f dash, is just the same thing. Right? Know that.